So the purpose of this video is to try to give a heads up on something that's new. We're working on Pivot. These instructions for this would be good for the Pivot assignment that I have, although this is for general physics and it's for April 22nd, 2025. This would be good for any time on this Pivot Lab, future years or whatnot. And in general. So the first thing I have here, I have a link. If you're not already in the class, you would need to click this link and it should get you right in. You're probably going to have to create an account, use your school email. If you already have an account, you can just click this link down here and it'll get you right in. That said, when you get to the assignment itself, this is the Pivot assignment. It is called Introduction to Transverse Standing Waves. It's worth noting that up here, I'm previewing this as a teacher, but I can show you multiple things about this. So to start with, the points right here, 21 points, is in Pivot. Whatever you get in Pivot is going to be out of a total of 18 in the Canvas assignment. So I'm giving some little bit of leeway. There's one of these points that is weird. I don't know. I can't figure out where it even comes from. And then this is just a tricky assignment. And so whatever you get on here will be out of 18. If you get more than 18, of course, it'll just go in and it would just be bonus points. So when you start working on this, your screen should look fairly similar to this. There's some places here you can type some observations. This isn't actually graded, but you can certainly type things here. When something is graded, it'll tell you it has this grade in, and it'll show you the score and whether or not you get it. If you just happen to say a number, submit answer, it's going to tell you wrong. It's going to give you some hints here, and eventually you can keep trying again. The truth is, it doesn't really take off points if you're wrong. Normally, you just have to eventually get it right before you can move on. It even shows you pictures, and it sees these little symbols here. That's what you would see. This shows you right here, and that's saying, hey, look, you can get a ruler. This can help you measure stuff over here. The way that this works, you have to press play, and then this is a video of an experiment that's taking place. What's happening is you have a string hanging on a pulley, and this weight is pulling on the pulley, and then you have a thing sending pulses down it at different frequencies. You can think back to our so I created this. We'll jump over here, and you should be somewhat familiar with this. In the Pivot, the pulsing action here is coming from this machine, which is making this speaker and send this little piston up and down. The tension is coming from this pulley that's hanging over the string. So the tension is coming from that weight that's hanging down. We'll restart that. And so a frequency is also changing. And so you'll notice if we can go super low frequency, and in the video, frequency is slowly changing. I can change dampening, but you'll notice there is a point on this frequency. I know that it's about, I think, 123, where you actually can get on the standing wave forming. At any rate, that's what we're dealing with here, just to familiarize yourself with that. You press play down here. Frequency's changing. You can see the string is changing. And as it plays along, you'll see things start to happen. This is something significant. This would be a standing wave with 2 loops here, we would call them. This is actually one complete wave. When you're dealing with earlier, that first thing you see, in mine it would be about right there, 12.5 hertz. That would be one loop. It is worth noting, let's see if I can pull this up here, that when you have that first loop like that, that this is actually half of a wave. The total wavelength would be all the way across here. Remember, this would be the complete wave. We have to go the same phase. So starting here going downward until the next place, we're starting here going downward. So this would be one wave. And it's going to ask you things, and you're going to want to put your ruler out there. You can measure. It's going to ask you details. It's worth noting, sometimes if you need a hint, you can always click there. You can put your answers in. I say 500 submit. It's going to say, no, you're wrong. And then you can keep trying to figure it out. You can keep trying these 100 hertz. It'll say, no, you're wrong. As you go along here, it's going to ask you questions. To do something like this, you could drag and drop, and you drag these over. And it's going to say, no, you're wrong. You can try again. It'll give you hints. As you're moving along here, this one starts to get a lot of people. You're actually going to fill this entire table in. All of this is pulling in data. And it's worth noting, you have chord A, weight 1, chord A, weight 1. So the data that goes here is just going to be frequency. So maybe I'll show you how to do the first one. Actually, I'll show you how to do the second one on all of these. So if you press play on this one, this would be your second one, and we'll eventually pause it. Whoop, right there. So this is what this is actually wanting here is basically the number of loops. So there's 2 loops here. What is the wavelength in this situation? Well, we can look at it. And since this is 100 centimeters from there to there, then that's easy. That's going to be 100. What is the frequency of chord A, weight 1, when the wavelength is 100? Well, it's 24.8. So we would type 24.8. Now, you would continue, you would do this entire column for all of the different loops on this one. As you continue to play, you'll notice it'll go to eventually it would be 3 loops. It would be right there would be 3 loops, and so on and so forth. But I'm going to not do that. I'm going to move on, and we'll say, well, what is the frequency chord A, weight 2? So this is chord A, weight 2. We can press play on it, and we'll wait. There would be the first loop. That would be this column, but I'm not doing that for you, or that row. There's 2. So once again, our wavelength is going to be the same, and you're going to find, obviously, the wavelength is the same for the number of loops because the distance here doesn't change. The frequency would be 20.3. There you go. And then we can do the final one down here. Chord B, weight 1. Chord B, weight 1. We can press play. Press play. Somehow. Well, apparently I can't press play because of the graphics. There we go. The graphic for the recording here We'll watch it when it goes to 2. Right there, we'll call it 32.7. So that frequency would be 32.7. 32.7. You'll fill this entire table up. So I just put a bunch of numbers in here. Now, please note, these numbers here are correct. The rest of these numbers are completely wrong. I just made them up. But as soon as you finish filling in this table, it's going to go ahead and create 3 graphs for you. Each of these graphs is relative to one of the columns. So this is chord A weight 1, chord A weight, chord A weight 2, chord A weight 1, and then down here it would be chord B weight 1. So you have 3 graphs, and each of those three graphs is getting their data. It's using this column and then one of these columns for each of the graphs. Now, a few settings. When you click this setting bar, you want to make sure to click Auto Scale View so you can see all of your points. And notice how these are dots right now. And you're going to notice an equation with numbers down here. Sometimes the folks with touch screens especially happen to accidentally do something like this, where you grab and you click, and then you end up with maybe your data is not working, maybe you get a little tiny amount of data down here, and you get all these X's. If you do that, you're going to want to click on the origin and then drag over and make sure to include all of the points. Basically, you're selecting the area you need to do. So if it's that goes to those X's, it's just not graphing what you've got. It's gonna, after you make that table, it'll automatically create these 3 graphs. I would go through and I would click Auto Scale View on them, but that's pretty much all you need to do at that time before you move on to part 3, where you're gonna start analyze your data. This question is asking you to look at your questions themselves, your data itself. Look at those dots and try to find a common shape. Now mine are, it's a pattern that is a line. Yours probably won't be, but you're going to try to find one of these that matches. And if you happen to get it wrong, it's just going to tell you to guess again.